Discover the collaborative efforts of HORIBA MIRA and Giti Tire in evaluating virtual tire methodologies. Mariano Carpinelli, Senior Multi-Body Simulation Engineer from HORIBA MIRA, and Karthik Tharanisingh, Engineer Motorsport from Giti Tire, present their innovative approach. Learn how they leverage the DiM250 Simulator to subjectively assess tire models efficiently and cost-effectively.
Buon pomeriggio a tutti e grazie mille a ViaGrade per l'accoglienza. Hi everybody and thanks a lot ViaGrade for having us. I am Mariano, I'm part of the MIRA simulation team and I'm very glad to be here today with Karthik to talk to you about a project we did in November last year, which was about the use of a DiM250 for the subjective assessment of tire modeling methodologies. So let me give you a brief introduction about MIRA and its facilities. So we are an engineering company. We provide services to the automotive industry. And we are located in the UK, in the West Midlands. And in this aerial picture of our MIRA Technology Park, you can see our MIRA Proving Ground, which includes several test tracks. You may recognize the ride and handling circuit or the dynamic platform in the north of the site. And we also host many OEMs and Tier 1 suppliers on our site. And we often get into interesting projects with them. That's also how we started our collaboration with GT. So they have an office on our proving ground. They've been using our trucks extensively in the past years for physical tire testing. However, in the past months, our collaboration has gotten an entirely new spin as we started helping them moving forward along the zero prototype path. As you may know, last year, MIRA acquired a DiM250 and built an entirely new facility to host it. We had been using ViaGrade simulators a lot, so they were embedded in our processes. We had our own compact simulator for many years, and we've been coming here in Udine to use the DiM150 several times. However, we wanted to give our customers the unique opportunity to have a DiM250 alongside our proving grounds. And now that's possible thanks to the new MIRA Driving Simulator Centre. So in order to propose the simulators as a valid alternative to physical testing, we had to make sure that our customers could experience exactly the same tracks and ride surfaces that they have been using on our site for a long time. So we had all our major tracks and ride surfaces laser scanned, and ViaGrade made accurate digital twins for us. So in the animation, you've seen our ride and handling circuit. And then at the bottom left of the slide, there's a picture of our ride surfaces. There's also a pic of our inner city circuit, which includes intersections and roundabouts. It's ideal for ADAS applications. And also, we've got a digital twin of our wet and handling circuit. There's also a ride route coming soon, which is being finalized at the moment by ViaGrade. So coming back to the main topic of this talk, so the scope of the project was to make it possible for GT to bring its professional test drivers on the DiM250 and replicate the same kind of subjective assessment that they would usually do on the MIRA Proving Ground. So the task for the MIRA simulation team was to create an accurate digital model of the benchmarking vehicle, which was a BMW 1 Series. And then the goal was to couple the digital twin of the vehicle with the tire models provided by GT and do a series of lateral tests on the DiM250 to assess different tire modeling methodologies on one hand, and also do back-to-back comparisons of different tire specs.
All right. So good afternoon, ladies and gentlemen. I'm Karthik Tharanisingh, and I work for Giti Tires, and I'm based in Hanover, Germany. So, of course, as an engineer making a technical presentation, I have to start with a marketing slide. So who are we in Giti Tire? So fundamentally, we are a global tire manufacturer, and we are able to spread out to pretty much all over the globe in terms of supplying for the passenger car market, the truck market, and also for some motorsport applications as well. And we produce our tires in China, in Indonesia, and recently we also have our plant in the USA up and running. And for the engineering and development, our R&D and test centers are also spread out all through the globe. Especially for the European market, we are based in Hanover, and as Mariano explained, our test center is headquartered in the MIRA Technology Park. But we also do some testing in Idiada, Spain as well. And our ambition as Giti Tire is to be more prominent in the European market space as a reliable partner to our OEM customers, and also be innovative and open up our capabilities in the ever-changing world of requirements to make future automotive products. Okay, in terms of what is exactly virtual tire development, I'm sure most of you sitting here are industry experts, so I don't have to explain, but funnily enough, I was a freshly graduated engineer last year sitting in front of my laptop watching this last year, the Zero Prototype Summit. So probably there's some students watching, and probably my mom also watching, so maybe that will help. So fundamentally, in terms of creating a bespoke product for an OEM customer involved producing hardware tires, and you go through an iterative process in also many subjective tests, objective tests, and this happens over time, so every single time you had a hardware loop. And of course, it was not that the virtual side of things was not happening. It was more of an analysis tool used to, as a tool by the development engineers to either have the requirements in hand to match the performance expected at the start of a project, or also during the iterative loops of creating spec changes to also have analysis. Time models were always used. But of course, we also see the industry trend in general. It's also moving towards the goal that we can do the iterative process in the virtual side of things, so that we can have fewer hardware loops. Probably zero is still far away, but maybe we start with fewer hardware loops, and we start doing the iterative methods in the virtual side. And of course, a big thing in using that is to also bring in the human in the loop, and that's why driving simulators come into play. And for us, it was a step into this world, thanks to leveraging the fact that MIRA had acquired the DiM250, and also we were positioned in MIRA. It made the logical sense to go ahead and also start exploring this world. Of course, there are many things you can do with a tire model, and as I explained, you can always go back and use it as a tool to also have a characteristic analysis for tools as a development engineer to assess ride and also handling simulations. You can also use curves from a tire, from a pure tire model, to also understand the direction that you know you need to go for a certain vehicle project. What we particularly wanted to focus on in this particular project was to understand this domain in terms of using the subjective side of things on a driving simulator. And of course, we wanted to not go through the entire sheet of the requirements, because that would be hard. So we wanted to first start with dry lateral subjective handling. And two questions that we wanted to address was like, okay, can we actually go ahead and subjectively assess some of these criteria? And can we also throw in a loop where we create these tire models from also a purely virtual standpoint from an FEM method? And can we see some changes that we know from prior experience? And the two boxes on the top where you see is fundamentally giving you the idea of the questions that we wanted to answer. And the box on the bottom is what we needed to do for the project itself. We wanted to focus on, like I said, just the dry, subjective lateral handling. And the requirement sheets are probably smaller than if anyone has seen a requirement sheet for a tire development project. But the scope was to understand the fundamentals to get it right. So you can see that it was mostly the on or around center maneuvers. And in terms of the higher dynamics or medium dynamics, we chose the lane change maneuver. And we fundamentally wanted to establish, okay, can we correlate it first with a physical tire on a real test vehicle to a tire model which is created by measurements, a flat track measured magic formula model on a simulator? Do we at least, can we assess it with a similar trend, relative comparison? And the box on the right is basically, we developed some specs from FEM techniques. We also characterized them to create magic formula models at the end, but from a virtual development. And we wanted to see if the spec changes that we incorporated in these virtual models also reflect what we know from prior experience and other tests from a subjective side as well. So in terms of requirements, we had to go out and build some tires to test it on the real prototype car, as well as, of course, we needed to measure them on a flat track, as well as use our FEM techniques to measure, to create models for 2 specs. And in terms of the vehicle modeling side of things, we had to we leveraged the experience from MIRA to create the models for us. So to just quickly go through it in terms of what we went in terms of our idea was when we went ahead and had the specification definition in terms of parametric designs. These are mostly structural changes to a tire. We wanted to have a good spread. So on the first block, you can see on the bottom, we have the cornering stiffness plots of all of these specs with a decently spread performance. So when we wanted to step into the simulator, we wanted to give the best chance for our drivers to also find some changes to start off with. And of course, to very quickly explain in terms of the modeling approach, we also had flat track measured semi-empirical models. And also, those were fully characterized. And from FEM techniques, we also generated a magic formula model, but only in lateral characteristics, purely because of computational time. And for the vehicle measurement, like we already spoke about, the target car was, or at least in this project, was a BMW 1 Series. And we went ahead and characterized it from a real car. So I'm going to give it off to Mariano, who's going to explain it more in detail.
Yep. So it's very important for Tier 1 suppliers like GT to have the capability of creating an accurate digital twin from scratch for measured data. And in MIRA, we've got all the test facilities required to do this kind of measurements and gather the right data. So we start from a KNC characterization of the suspension, and we also do the mass inertia measurements. We've got 2 ABD rigs to do that. And we also got an MTS rig for the damper characterization. So we do the KNC tests at different ride heights to try and achieve the best possible accuracy in the suspension model. And then we've got an automated population tool that we've developed in-house to automatically feed the KNC measurements into the VA-grade KNC wizard and get out a real-time model in an efficient way. So in terms of steering parameterization, so we know that the steering feedback to the driver is so important. It can be considered like the foundation of the whole simulator experience. And we need to pay particular attention when we parameterize it. So our approach focuses on the identification of the main parameters of the advanced steering model in the real time. And relies only on a limited number of static steering tests and full vehicle tests. Once the real-time model is fully parameterized, we then go through an offline in-depth correlation study. We also do this in an automatic way. And we consider all the most important vehicle dynamics tests to characterize the steady state and transient behavior of the vehicle. And also we make sure that the steering parameterization results in the correct levels of steering wheel torque in the on-center region, which was particularly important for this project for GT. And then we put the model on the DiM250, and we let our professional test drivers try it and make sure it's representative of the benchmarking vehicle. And in this phase, we also set up an initial motion queuing that we then use it as a basis with the customer, in this case with GT. So once the model has been signed off by our test drivers, we hand it over to the customer and over the word to GT.
OK. Just a brief explanation about what we did exactly in terms of our test plan. So just to recap, what we wanted to achieve was just to see where we stood in terms of lateral handling characteristics in the dry. And yeah, as steady state as possible. Of course, in reality, it's never this case because there will always be an influence from the powertrain. But within the scope of what we wanted to achieve, we set out in an approach of testing where we sent out the test drivers, each getting 3 laps at a fixed speed to do all of these maneuvers. So coming on to the physical side of things, so we used the number 2 track in MIRA, which is essentially 2 long straights with a constant corner at each end, which is enough to capture what we wanted to do in terms of a criteria list. And of course, we had 3 drivers to do this test. And on the simulator itself, this was a new world for us to come into the simulation domain. So for us, it was a first step. So we had an adaptation program for the drivers to get used to this environment as a first, and also working with MIRA to dial out the motion queuing, which is a topic by itself, to be honest. And the approach that we went ahead with was to have a common motion queuing for all drivers. Of course, there's approaches where we can use individualized motion queuing for a particular driver, but we wanted to remove any variables for the first test. And the setup that we used for the track itself was a 3-lane highway with corners at intervals so that we could assess, again, the criteria that what we wanted to see. Quickly going over the results. In terms of what we set out at the start of the presentation in terms of correlation and what we could do in virtual development, the metrics which matched to a fair degree of strength was, of course, the on-center. Steering response and steering torque is something that we could robustly identify between the domains of the physical tire as well on a real car against the semi-empirical models, which were measured. Of course, the steering angle requirement, it was to a decent degree of let's say, statistical accuracy. And the keenly-eyed observers of you who still don't have the need for caffeine, in terms of the lane change, that was something that we struggled to find some correlation. And we already have some ideas into why that's a particularly hard component to verify on the simulator. And coming on to the virtually developed specs, what we wanted to see, like I said earlier, was to incorporate a spec change in a reference model and a further model, and to see if these were subjectively verifiable on a simulator. And what was interesting is that the subjective comments from the drivers matched with our expectation of what such a spec change should do, as well as a trend-wise performance characteristic. So the plot on the right, you can see the conic stiffness, again, of these 2 specs. The one on the top is from the measured models. The one below is from the virtually developed models. Of course, the trend is the same, but you can definitely notice that it's not ignorable that the difference between these 2 in terms of the divergence is something that we tend or we want to improve in the next time around. So to just conclude, because we definitely are running out of time, in terms of what we set out to do was to delve into the world of using driving simulators to also subjectively assess the tire development strategy. And thanks to MIRA, we were able to characterize a vehicle model for this. And we had a good first step for our test drivers to get into the environment, and a decent correlation of soft handling characteristics. And the next steps, we want to explore more into the higher dynamics part of it, try to use the simulator for a bigger array of the specification sheet, which will include ride as well in the future. But for now, we've kind of captured everything that we did in a cool video as well, so I will let that to you guys.
It's very strange, but then very quickly, the even stranger thing is how immersed you become. Its capabilities are broader than I expected. I had to remind myself that I was in a sim at one point. GT is a global brand with expansive global reach. We produce tyres for truck, bus, car and motorsport application. We're based at MIRA Proving Ground, and we test for all of GT's global activity.
So primarily my role as a test driver, I do all the different range of testing. So that's grading of various different aspects of the tyre's performance to make improvements for future loops and to develop the final product.
We've had a modelling department at GT for over a decade now, and we've come to the point where we needed to take that to another step, and it was just the perfect timing to move forward with a partner that we are tenants of, and this enabled us to achieve exactly what we wanted at the right time.
GT had realised that moving into simulation and simulators is the way the market's going. They need to be able to respond to that. So actually this was sort of the first step for them of just trying to understand the capabilities. So first of all, we just had some familiarisation with them, just give them the chance to drive the simulator, learn about different scenarios, understand about what cues the simulator's doing, how to respond to it. But also they're trying to match it with some of the work they're doing out on the proving ground. So making sure there's that synergy between the tests they do in the physical world, but also they can bring that into the simulation world.
I came in open-minded because you can have some negative impressions of sim before you've been involved in it, but I left impressed. What we imagined we'd achieve in, say, 5 years, 10 years, we've actually achieved in 1 year. So hand in hand, that helps us with our sustainability targets. That will have a huge impact on what we do.
Surprisingly, it doesn't take that long to get used to it. Once you've got somewhat acclimatized to it, it's surprising how quickly you can start to get fully immersed in it. You know, the more you drive it, the more subjective points you can start to pick out from the handling evaluations we were doing, similar to the points that you'd start to pick out on a real tyre on the test tracks. What really helps is you're in a real car with a full interior. All you can see is the screen, and you've got the motion from the motion platform. Yeah, it really helps you to get immersed into the experience.
Yeah, perhaps in the past it was okay to take 4, 5, 6 years to develop a car. Actually, the technology that's going into the cars is moving so quickly that if the products that are being delivered don't keep up, they're going to be out of date almost before the release. So the simulator allows us to look at a wide range of technologies. We can easily look at different setups as we're applying it to different vehicle platforms. We can assess all those areas in one go in a much quicker, more efficient way.
This project has highlighted the ability to look at all aspects of the vehicle and take a single component such as a tyre and understand how that can perform in the virtual domain for that end user, for the person that's going to buy that product. We're able to do lots of iterations of different vehicles within here without the need of producing lots of prototype vehicles and shipping around the world of people and parts. So they're able to now start assessing their tyres in the virtual domain rather than relying on prototypes. So their customers are buying a better product on the market.
It was exploratory, but it was also a coincidence of events that came together at the right time. Honestly, if we weren't at MIRA and we weren't approached by you guys selling your aims and your project, I don't know where we would have begun with this. And I don't think we'd have got as far as we have now.
With that, thanks for your attention.
Yep, thanks a lot. If you have any questions.